Okay, let's try problem 2.24. Figure on the right shows data for the speed of blood in the aorta. Determine the magnitude of the acceleration for both phases, speeding up and slowing down. Okay, if you remember, the equation for acceleration is simply equal to the change in velocity, over the change in time. So if we're actually given a plot like this, it's simply just the slope of the lines. So if you notice, we have one line that's speeding up, that's going from a low velocity to a higher velocity, and one that's slowing down, that's going from a high velocity to a low velocity. So all we have to do is calculate the slopes for the speeding up part and the slowing down part. So for the first part, right, slope is just rise over run. So we're going from here to here, and so this is right around 0.75. And it's meters per second because we're on that y-axis. And then that goes all the way to 0 meters per second. And then our change in time is simply going to be from here. So it's going to be, we'll call that 0.25 seconds minus, right, and then we're going from here, so 0.2 seconds. And so this is equal to 0.75 meters per second over 0.05 seconds. And this comes out to be 15 meters per second squared. 15 meters per second squared. Okay, so that's our acceleration for the first one. Notice that it's positive, so it's increasing, which makes sense because the slope of the line is positive. Okay, so we'll call this A1, and then we'll call second acceleration, that's decelerating, A2. So acceleration is equal to the change in velocity over the change in time. And so we're going from this point to this point over here now. So let's start with 0.75 meters per second. We're just calculating the slope again of the line minus 0 meters per second, right? Because we're going from here to here. And then over the time for this section, so this is 0.25 seconds minus 0.40 seconds, right? Because we're going from here to here. And so if you notice, this denominator is going to be negative, which just goes, that'll give us our negative slope. So it's going to come out to 0.75 meters per second over 0.15 seconds. And then this comes out to, this is negative 0.15 seconds. This comes out to negative 5 meters per second squared. So that's our slowing down one. And just by looking at the numbers, you can see that this section increases way more quickly than this section. So that means we have a bigger acceleration here than we do here, which makes sense. And that's problem 2.24.